This video is on simplifying radicals. I'm going to be doing some examples using the information that I've already provided in a separate video. So the directions will say to simplify completely. We have to make sure we completely simplify it so we don't have any other numbers that can simplify further. So again, we want to look for the biggest perfect number that divides evenly into the radicand. So again, we're going to look at the radicand. We have to take the radicand and divide it by the numbers that are in the list. We determine which list to focus on because right here I have 4 different lists. I have perfect squares, cubes, fourths, and fifths. We determine the list based off of the index, which is also considered the root. So the index number, if it is a 3, I would look in the cubed column. If it is a 5, I would look in the fifth column, the perfect fifth column. On Simplify Completely, we have a radical 20. So this radical, if you notice that there is actually no number inside the index, the number that's actually there is a 2. Just like if you were multiplying, if you had x times something, the number in front of the x would just be a 1. You don't actually have to write it, but it's there. The same thing happens with a radical. If you don't see a number inside the index, it's actually a 2. So this index is actually a 2. You don't have to see it, but it's there. That tells me that in the index, I'm going to be looking at the perfect square column. So I'm not even going to focus on these numbers over here. So what I want to do is find the biggest one of these numbers that can divide evenly into the radicand. So I have to take the 20. Now what I do, I need to make sure I check all of them that are possible. I start with the biggest number, 225. 20 divided by 225 I know will not work because that is way too large. So what I do is I know I have a 20, and I go up the list until I find a number that is smaller than 20, and I start there. So I know these numbers are too large. I keep going. I see a 25, and then I see the 16. So 16 is the first number that is smaller than 20. I have to make sure I check all of the numbers from 16 upwards until I find the first number that works. So what I do, and I can use my calculator for this, I'm going to take my radicand of 20, and I'm going to divide it by the 16 first. So divide it by 16. That gives me a decimal. We want whole numbers. We want all 3 of these numbers to be whole numbers. So 16 is not going to work. So that means I go up the list again. So I do 20. Now I'm not going to clear it because I want to make sure that I use all my numbers and I don't want to repeat them. So I've used a 16. Now I go up to 9. So 20 divided by 9. That also does not work. So I keep going because I want whole number, and I want a whole number here as well. So I go up to 4. So 20 divided by 4. That one does give us a whole number. And the reason why we want to see all whole numbers is because what this does is we have the square root of 20 is actually rewritten as equal to 2 square roots multiplied to each other. So we have a square root times a square root. I have to make sure I keep the same index in the problem because otherwise if I don't, then that will just completely change the problem. So this is still a square root and a square root symbol. So I already have the 20 on the calculator. Then I have a 4 and a 5. Well, all 3 of these numbers have to be written here. So I already have the 20. I need to put the 4 and the 5. Because understanding this, the square root of 4 times the square root of 5 is the square root of 20 because 4 times 5 gives us 20. Now the reason we do this, and if we find the largest number that works in here, we only have to do this once. But if we don't find the largest, we might have to do it 2 or 3 different times. So the reason we find the biggest perfect square is because now, if you look at this column, the square root of 4 is 2. It actually comes out to be a nice clean number with no radical left on it. So this would become 2. The 5, the square root of 5, since we did find the largest perfect square that went into here, that means that the square root of 5 will not be able to be simplified. So this is times the square root of 5 still. This becomes our coefficient. Our index is still 2, and our radicand is now 5. So our final answer, because the coefficient is multiplied by the radical, our final answer is 2 square root of 5. Now again, you can put the little 2 inside of the index, but it is not necessary. This is our answer, 2 square root of 5. And to make sure that we are at least on the right track, I can go into my calculator and type in the square root, so second square root symbol, 20, and I will get a decimal value because it is an irrational number. Now I'm going to check 2, then the square root symbol of 5, and then I see that I have the same decimal. So I know that I have at least simplified it. But the biggest question is it simplified completely? Because the 5 cannot be simplified further, and I can check that. So my radicand is 5 now. Because my radicand is 5, I again go back and find the biggest perfect number that can divide evenly into the radicand. So my radicand was 5. 4 would be the biggest number possible. So 5 divided by 4 would give me a decimal. But then I move up. 5 divided by 1 works. So if that is the only one that will work further, the ones, that means that this is simplified as much as possible. If there are no more numbers that will divide evenly into the radicand, that means it is simplified completely. So you must always check your radicand again, just to be on the safe side, so that you can determine if it's simplified completely. Because it might still have the same decimal, but it might not be simplified completely. That's the biggest word, completely. So if we go to example 2, example 2 says, to simplify completely, this is, since there is no index in there, since there's no number in the index, it is a square root of 864. So on this problem, we again look at our radicand. It's a square root, so we look into our perfect square column. 864. Now 225 is the largest one we have on the column. That does not mean it is the largest number possible though. So when we do this, we definitely have to make sure that our radicand that we get cannot be simplified further, because it might have to go further because we don't have all of the numbers listed out. So we take the 864 and we divide it by the biggest number possible. 225 is smaller than 864, so we can try and divide that. So we take 864 and we divide it by the 225. That gives us a decimal. That is not good. So we keep going. 864, again, I do not clear it because I want to make sure I use the same number, and then I know which number to go to next because it's on the list. So we have 864 divided by 196. Also a decimal. 864 divided by 169. Also a decimal. 864 divided by 144. That is a whole number. So now we can rewrite this as two radicals multiplied to each other. Radical times radical. And again, this is a square root, so we can put that 2 inside that nook, which is called your index. We do need to make sure we keep the same indices. So 864 is already written. Then the next number was the 144, and then the next number is 6. So all three of these numbers have to be written. 866, 144, and then 6. So the reason we do this is because the square root of 144 is 12. So we can write down 12 times the square root of 6. Now before we determine if this is, or before we write our final answer, we need to make sure that this square root of 6 cannot be simplified again. Because 225 was the largest one, but there are absolutely more numbers that could potentially have gone into 864. We have to check the 6. So our radicand is 6, so we look at our square root numbers and find the biggest number that's possible. Still not there. 4 is the first number that is smaller than 6. 6 divided by 4 gives us a decimal. So we know 6 divided by 1 is good. That means that the square root of 6 cannot be simplified further. That means that this is our final answer. We just write it as 12 square root of 6. And again, we can check this by doing the square root of 864, and we'll get a decimal. And then we'll do 12 square root of 6, and we get the same decimal. That means that we have simplified it at least. And because the 6 cannot be simplified further, it is simplified completely like it asks for. That means that this is our final answer. So I'm going to go a little bit quicker through these next ones. On this third one, notice that the index has an actual number in there. That is a 3. That means we have to specifically look at this column. But when we find the perfect number that goes into it, we still know that our answer will come from here. So we have the cube root of 432. The cube root of 432. And you can always check to see if that number is actually listed on here. Because if it's already listed, you already have your answer from here. You don't have to use your calculator. So 432 is not listed on there, but 432 is our radicand. We have to look for the biggest perfect cube that goes into 432. So 343 is smaller than it, so that's the first one we check. So I'm going to clear out my calculator. It was 432 divided by, we're going to start with 343. So 343. That gives us a decimal. So I'm going to go 432 divided by 216. Gives us a correct whole numbers. That means that we can write this as two different radicals. So I'm going to move this. This is a radical times a radical. But we got to remember to make sure that our index stays the same in the problem. So this was a 3. That means that this has to be a 3 and this has to be a 3. Now the numbers were 432, 216, and 2. So I'm going to put 216 and then 2. That is 216 and 2. The reason we do this, again, is we look back at the 216. The number that actually gave it to us was the 6 cubed. So the cube root of 216 is 6. That means I can take this number and it simplifies down to 6. Then I have times the cube root of 2. And again, we want to make sure that this number cannot simplify further. So again, we're looking at the cube root, so this column of 2. The first number that's smaller than 2 is the 1. So that means if it's just the 1, if nothing else works, then it is simplified completely. So our answer will be 6 cube root of 2. So our coefficient is 6, our index is 3, and our radicand is 2. Make sure that that 3 is inside that nook and not attached to the 6. This would be our final answer.